also found the Miskatonic University parking.
Nice.
Oh, nice.
So we did what?
And maybe Tesla's gonna give them parking, those parking permits for their.
Really?
But that charging station.
No, I thought having the right receptacle was sufficient.
Oh, for
Usually
crying out
that
loud. Now
is-
what?
It's a sign for Tesla's only. You have to have the right logo on your car.
Do you have the Cape Cod Tunnel?
Oh, yeah, that's a classic. For a while, there was a webcam page for the
Oh, is that right?
You know, I was at Wegmans.
It was a pretty good thing.
Yeah, yeah.
It's sadly gone.
I was at Wegmans this morning, and Wegmans actually in their parking garage has a number of charging stations. And I have noticed that some non-electric car was parked there.
That's not
But I've also seen complaints online where in the Prudential Center garage, there was some entitled
tax at your roadside service station, and they'd charge the stack of packs.
You know how heavy the batteries are?
It was a interesting idea, but yes, you're getting into some heavy material handling equipment, and somehow automated forklifts are even scarier than the Tesla moving itself sideways in the parking lot.
Tesla batteries weigh 2,000 pounds. They're not gonna have swappable batteries until maybe solid state batteries come out.
What you could, there are moving parts in your battery?
No,
Well,
non-dry battery.
there
They can
are,
have solid state.
I think they did a experimental modeling a battery basically using a single wire so that they could figure out what exactly was happening inside the battery and why they slowly degraded. And when they charged it up, the wire was turning into this little sort of basically almost this tangle, and when it was discharging, the wire was straightening out. So apparently, even in nominally solid state batteries, may very well be atoms moving around.
Well, yeah, chemistry is atoms movement.
Well, the thing is that all your lithium batteries today are liquid based.
I was actually under the impression that Tesla's already working on the technology of the superchargers to replace the batteries. I remember reading that they started working on that a few years ago, so I wouldn't be surprised if that's right.
They've talked about it for a while, but the batteries right now are just too heavy.
Actually, I forget which model it was, but there was like their SUV. It was the first SUV to ever score perfectly on a road test because the center of gravity was moved so low by the batteries that it actually would completely right itself every time they tried to flip it in tests.
nice.
So this problem with the batteries is why the Formula E electric car races, which is sort of partly between Formula One style and Milan style vehicles, each driver has two cars, one that charges while the other one's racing.
Right,
And a pit stop consists of jumping out of one car and into the other.
What would actually, or should actually be reasonably possible is if instead of having a 1-ton battery, is if you say break it into 100-pound segments and ideally put in standards so that the batteries are the same between different vehicles, and you just have basically you change 20 packs. That requires rather lighter equipment.
Yeah, but then if you're changing 20 packs, then that's going to take longer than
The actual battery in a Tesla is actually about the size of a double A battery.
Yes, thousands of them.
The 16380 cells, right?
Yeah. They put them in a module and then put them all together in a battery pack.
The guy up in Cape Ann did like lovely video.
Yeah.
Okay.
So a couple,
It's like the world's largest Roman candle.
yeah.
They launch in each cell.
Good.
Yeah, but the thing is, if you have like 20 individual cells and say have a robot doing it, it will basically, you could literally have this very tiny conveyor and move.
Yeah, but you gotta
Not
be
so
careful
very
the robot
tiny.
doesn't turn on.
The thing is, once you know where the exact position of the car, you can swap out all the batteries fairly quickly.
Jennifer, how are you doing?
Just about there.
Okay.
When they get there with AI, they'll find out that they're not getting paid and get a union.
It's not
Yeah, if the AI does social, it's not some trouble.
Don't laugh.
the AI.
But for those that don't know, the Tesla battery, you have the chassis of the car. The battery sits directly on the chassis, and then the body and the seats and everything are above that.
Yeah.
So it is a very, very low center of gravity. Corners very well, especially the four-wheel drive versions, which is what I have.
Was this the model that they actually thought of making the carriage swappable, and you just put on, get rid of the carriage and the batteries and slap the rest of the car onto? Wasn't there going to be a swappable model that like maybe they built the carriage out of batteries? Is what I was thinking. Didn't they talk about that?
I don't know what on the Model S and the Model X, which is the SUV,
Yep.
share the same chassis.
Oh, they're identical.
Yeah.
Basically, the passenger is to the Tesla battery as McGotter's collectible Disney iPhone case is to the iPhone.
Yeah. Well said.
Okay. I'm going to start right now.
Tesla's a battery company.
Yeah. So you can't accurately weigh things inside the Tesla, is what you're saying. Gravity will throw off on those too. So the Formula E crowd was at MIT a week ago, right? The winning team, the TE Cheetah team.
Yeah.
They were here asking about what we're doing with autonomous vehicles, because they do have a Formula E autonomous class. They just don't. They haven't done anything with it yet, at least not in the U.S.
So same as Uber, they're trying to get rid of the overpriced talent in the car.
Yes. The prima donna.
Let me know if they offer you tickets to the grand finale in Brooklyn.
Oh yeah, for sure.
Okay, we now have the live feed going. Jabber got a brand new laptop. Well, it's about 4 years old, but it's new to him, with an SSD drive in it. And hopefully the YouTube will work. For this part of the meeting, we're going to be talking about the history of the BLU and the history of the Boston Computer Society, which is really where we came from. And again, before there was a BLU, the BLU was actually a special interest group of the Boston Computer Society. At that time, when Linux started, I was the head of the Atari 16-bit group. John and I, before that, early in the BCS, we set up a mail server for the BCS. We originally started to use SCO Unix, but we had such crappy hardware that it really didn't work, so we ended up doing it under DOS. And so
Yeah,
Jabber set that up himself.
There's basically a BBS system called Waffle that used Unix UCP to exchange mail with other sites.
Right.
Really?
Yeah.
And we should mention that that's when SCO Unix were the good guys. Before they were the bad guys.
That's when it was the original SCO.
The real stuff.
The real SCO, I can give you some history on SCO if you want, but SCO was purchased by a Linux distribution company in Salt Lake City. And that's when everything went to hell.
Yeah.
Who was that?
It's not Novell.
No,
They were up there.
it was
Caldera.
Caldera.
All right.
They bought SCO, and they thought they were getting the rights to Unix. If they had the rights to sell Unix, but it was Unix Systems Labs that actually owned Unix, which was actually sold to Novell, and Novell ended up owning Unix. And Novell essentially, on the lawsuit where SCO was actually suing IBM, Novell actually waived the right. So, knocking the pegs out of the whole lawsuit.
What kind of hardware did you guys use back then?
It was a 286.
Is that model?
Amazing.
The first one.
Okay, Boston Computer Society. This was their old logo, BCS. This is their newer logo. And BCS was actually founded in 1977 by Jonathan Rodenberg, who was 13 years old. He started in his bedroom, had a business phone in his bedroom for the BCS.
As you do.
And many well-known figures. I know Dan Bricklin, Mitch Kapoor of Lotus, and a few others. Many others sat on the board. BCS. BCS was organized basically with hardware groups that were along the different hardware platforms: Atari, Commodore, IBM PC, Apple, and all the special interest groups, which was based on software like Lotus, which became Spreadsheets Linux, and stuff like that. And at its peak, the BCS had about 35,000 dues-paying members.
So can I ask on that?
Yeah.
Not to challenge you, but from the BCS Mac perspective,
Yeah.
my recollection is that group was over 30,000 by itself. So BCS must have had, and the IBM group was
BCS.
bigger.
The IBM group was.
Anyways, it was a huge number. At
I'm
the time.
saying is these were 35,000 people that paid dues to the BCS.
Yeah.
Okay, the Mac group was a pretty big group. They had. Now I didn't talk about the magazines. That was also helped to bring down. The Mac group and the IBM group had professionals producing their magazines because they had people from O'Reilly. They actually professional publishing people that actually were producing the magazines. And the BCS, the actual BCS magazine was never very good, but it was a glossy magazine and could never compete with that. But even when it was very good, the Mac magazine actually was losing money. It's costing the BCS a fortune.
That's good.
But the Mac group also was almost very self-sufficient because they brought in their own revenue. I don't want to get into details like that because it's just memory. And the vendors were really the major thing. You know, you got an IBM, you've got an Apple, you know, and you got an Atari, you got a Commodore. Those are the big vendors for desktops at that time. And desktop computing was very new. People really didn't know what the hell they were doing. Whereas they know a hell of a lot more today. Kind of you don't know they do, but they do.
I used to go to the Apple II meetings at Solomon Schechter School. Remember, that was when the Apple II crowd was getting a little militant because it looked like everybody was in Macworld and Apple Fest. Kind of.
Yeah, I knew. Well, I knew Gary Haffer, who was one of the founders of the Apple Boston, which actually merged into the BCS.
Yep.
Like I say, he lived in Waltham. I used to have dinner with him occasionally in his wife's facility.
Was there like a Mac Tech group that was
Yes.
a little
Yep.
more? Yeah. That was a
Is.
subgroup, right?
Mm-hmm.
Still exists.
Still exists, yeah.
It just beats. Here, I'll talk a little bit. I can't talk about Federico anymore. Have a pizza.
Or two.
And
Yeah,
you have a
that group
piece of
met
cake.
twice a month.
What?
I said they met twice a month. They probably still do.
And we actually, in 1905, while it was still part of the BCS, we did have Linus. He spoke, it was here at MIT, it was in a larger room than this. We had a stage and everything else, and it was full.
We had at least 700 people in the room and a whole bunch of
We
people
could
outside.
hold
that couldn't
600 seated, and we had a lot more. So it was,
So how did that happen? I mean, somebody sent him an email, or he picked up the phone and said.
No, John Hall brought him over for the Women's Group in New
I knew-
Hampshire. And while he was in town, we also had our meeting.
Mad Dog Hall worked as close as my desk used to be at Red Hat Federica. Just could walk around the corner and pop into Mad Dog's. Oh, Mad Dog really was a friend of Linus.
At DEC, this was when you were at DEC, or he was?
This one I was DEC.
Yeah,
And I was always a contractor at DEC.
yeah.
And Mad Dog got up to speak. He brought his girlfriend with him, which is now his wife,
Mad Dog's girlfriend or Linus's girlfriend?
Linus.
I just wanted to straighten that
I don't know if Mad Dog ever had a girlfriend.
out. Maybe not.
But anyway.
So he knew him from what was going on. That's really interesting.
Yeah, well,
Didn't Mad Dog send him a Deck Alpha?
I sent him a Deck Alpha.
Oh.
Me. Believe it or not, Mad Dog sent out a message, we need an Alpha for Linus. I had one in my office that I wasn't using, and it belonged to the people that were gonna send it out to him, too, so I didn't have to do any paperwork. All I had to do was take it out of the building and take it down to Marlboro and give it to a guy.
Those were the days.
But it was a underpowered Alpha. It was,
That's the way to get stuff done.
yeah, it was a tower unit. It was one of the earlier Alphas. And then he got one.
Do you think he actually used it? Sorry. Yeah.
Absolutely, that's
what-
why
really?
Linux is successfully multi-platform. It started life multi-platform really early.
So did Windows NT.
Oh, yeah.
Yes.
Windows NT came out on the Alpha and on the 386 at the same time.
Yeah.
I worked on the compilers for NT Alpha.
Yep.
But the very first Linux really was, I mean, it was machine level trickery on the PC architecture. It
Oh, of
wasn't,
course.
It wasn't multi-platform to start.
No,
So you pushed him in that direction. You enticed him in that direction, right?
Linus was enticed by 64-bit. I think Mad Dog probably, but he wanted to. That was one of the things he wanted to do was go 64. Okay, in 1996, the board, and I was a member of the board at the time, decided the BCS was broken at the time, and we had, the costs were too high. The previous general manager, whatever the hell he was, gave us some stupid lease out in Waltham, which never should have happened. We had a pretty decent deal at One Kendall, but One Kendall was going to throw us out anyway because we had too much of a cheap lease. Our activists had lost, we had a lot of politics between activists, hundreds of activists, and you get into some of these meetings where the head of the IBM group used to call us little guys the lower 48. And then you got Marty Hannigan and those guys. It was really kind of a mess.
It was.
And then it was, believe me, it was worse than Washington politics. And we decided to shut it down rather than go through a messy bankruptcy. The plan was that there was going to be money left over, and that money was going to go to the Science Museum. And the Science Museum didn't get a penny. Once we shut down, it was the lawyer that kind of, I think he took me.
The computer museum got a fair chunk of
The computer museum, rather, not the
science museum.
science.
So the computer museum, does that still exist?
It went to the West Coast,
Yeah.
and what they left behind went to the Science Museum.
Yeah.
Oh, okay, good.
Yeah, that was actually
They're
run
in Mountain
by,
View now.
that was run by Gwen Bell, who was Gordon Bell's wife.
It's pretty impressive out in San Jose if it's still there.
Yeah, Gordon Bell was a longtime deck engineering manager.
The building that they occupy now is the old SGI.
Huh.
And
Museum keeps its own, right?
and it said John was a longtime activist at BLU, at the BCS, and set up the first mail servers. Also, John,
Actually, I set up every internet mail server that was ever there until they went bankrupt. The Waffle one, then the one on the next
Yes, you
cube,
did.
and then the newest one.
I tried to set up the first one, but SCO just wasn't going to work, and I am not a DOS guy.
I was also responsible for the BCS. I was finally buying an internet connection. They were dragging the heels of that. So one day I tried using PPP over a telephone connection, and the cost of the message units for the phone were more than it would have cost for a month of internet service.
Oh, that was
Oh, yeah.
so totally ridiculous because we had the internet.
Yeah.
Anyway, there was a lot of stupidity. Anyway, John formed the Linux and Unix Special Interest Group. And in 1994, Elaine Centangelo was able to make a deal with MIT for our user groups to meet here because we didn't have the facilities of that.
Wow, that was cute.
That was a big,
That was a big deal.
Well, the Atari 8-bit group, I forget the lady's name, but one of the activists in the Atari 8-bit group worked in the scheduling office. And she and several of the groups already met at MIT. So Elaine actually made it official. So that's how we got grandfathered in. We've been primarily meeting here at MIT since then. So we didn't, theoretically, when we came in, we didn't need a sponsor. So I always use Kurt's name when they ask us about a sponsor.
Yeah.
Hey, you remember that incident with John Robards?
Job
And,
security.
The what?
John Robards and Al Willis. You were on the board at the time.
Yeah.
I remember I was having some financial trouble, so I didn't renew my membership. I remember John Robards noticed in the membership database that I wasn't a paid member, so he went to the board of directors to get me kicked out of the BCS. I don't know the details. You were on the board, so you should know the details. But instead of kicking me out, they gave me an honorary lifetime membership.
Yeah, I think Pam was behind that.
Pan by Bell, right?
Pam by Bell.
Pan by Bell. Those are the days.
Run into a little bit later. By the way, Elaine's brother and I have lunch about once a month. He's a Vietnam veteran. He was in Vietnam. He was the crew chief, actually crew engineer on Chinooks. So he was there. I didn't know him over there. I just haven't been talking to him one day in one of our meetings. I found out his last name is when I first joined the Boston Vietnam helicopter pilots group. And he said his name was Centangelo. I said, "Oh, do you know Elaine?" He says, "Yeah, my sister." It's really a small world.
Do you know his other sister's name?
No, I met her.
I went to grade school with her, talk about small world.
Really?
I didn't know you went to school.
Well, I took the short path.
Okay. All right.
It is a small world.
And that's about all for my talk. Kurt, I think you're up next.
I think we're
Ed?
yeah.
Sam, you ready? Want to come sit up?
That was great, Jerry. I didn't know, a fraction of that.
There was a lot of shit, because I was a member of the BCS, not back in the 70s. I wasn't, I was in San Antonio when the blizzard of 78. And they didn't have any blizzards down in San Antonio.
The other office down in Government Center?
Oh, yeah.
I certainly do. I knew how to get free parking. The when parking meters weren't free at certain times, so I always time my visits to get.
I remember I got an advance notice when the BCS decided to close down. I wasn't supposed to hear this, but I was at work and I was telling it into the mail server to fix something. So I called up the office to have them reboot it. And the person answered the phone and told me that the electricity in the whole office building is down. All the computers are down. And I knew that wasn't true since I was telling it into thing. So I gave Jerry a call and he realized I knew it was up, so he explained what was going on.
Imagine that, a 13-year-old kid, 13 years old.
Yeah.
And, to bring together that many people
Yeah, well,
from all over the world.
he had an idea, and you hear all the time that young kids have an idea to do something brilliant. And Jonathan did it. He was a pretty smart guy. His father was a judge, pretty well-known judge, if I understand it.
I think probably also the case of the five things that seem interesting to them, and you just get really, really lucky because the timing was perfect.
Well, some of the timing is
Frequently, that's an advantage.
Sometimes it can get you in trouble by doing something.
but essentially the key was people, the BLU, the BCS was an educational organization. Our first internet address was bcs.edu. And I had a big argument with Barry Porter about it, that it really should bcs.org because it's an organization. It's not a college or something. But BCS did a lot of educating. Almost all the education was done by volunteers. And when it got too political, volunteers doing that kind of left.
I remember in 1994, one of the most popular classes at the BCS was called How to Use a Computer.
Do they charge for those classes? Or
Yeah.
They charge a few bucks.
Okay, I think we're.
I actually taught one of those classes once. Some guy showed up for it, but the instructor decided not to show up. I have to do
teach
this.
a couple of courses that way.
So it's nice to be back here tonight for the anniversary meeting, but we were here 3 years ago, some of us with 2 years ago, for a summer program that we started down in Cape Cod to mirror a program here at MIT, MIT Beaverworks, with the MIT RSS cars, and this is the third summer we're running it. Two of the original members are here, Ben and Liam are here. Ben and Sam, sorry. And so basically, what happens is in this course, in this environment, it's meant to expose high school students to the fundamentals of emerging technologies. And one of the ways with this course, it introduces a Linux operating system using Ubuntu, Python programming, and robot operating system. So we've just gotten started. We're entering our second week. Some of the kids started literally a week ago. Some started 2 days ago. So we are here tonight. They were up here today for a day with the group that's actually doing it residentially here for a month. And hopefully got some experience with that. And they have a little demo they're going to prepare for you. We're having a couple issues with the hardware on the cars right now, but they can do a demo and they can explain to you the gazebo, which is a simulation environment to test your code in.
Yeah, so my name is Sam. I did the original race car program in 2017. Last year I came up here to MIT for 4 weeks to do the actual program in the CogWorks program. It's an AI program. And I'm back this year at Mosset as one of the TAs. And if you can just go around and introduce themselves if you guys want.
So I'm Ben, I was one of the original members. And then last year we had at the satellite program at the high school, we had a synthetic aperture radar course that I was part of, and then I'm a TA again this year.
I'm Christian. I just started last week with this program. So, yeah.
I'm William. I've started 2 days ago, but I've been doing the course online. Been working with the Python core and Git.
I'm
Ren. I started like this week, so.
So yeah, we got some new people. So as Ed mentioned, the whole program is about like the car driving autonomously. So I've got tonight a modified version of the code we ran last year. I like to tell people it's the code I wrote last year, but it actually works this year. Yeah, it still worked last year, but the day after the race, I found out that an entire section of the code didn't run, and it runs now, so that's great. And so this is something that the current students are working on. They're not quite there, but just to give you guys a demonstration, we've got the code from last year. So because we don't want to test, completely untested code on a $5,000 race car, because that's just dangerous, we have a simulation program called Gazebo that we use, so I'm just going to launch that up right now for you guys.
Can let you hack into my Tesla.
So we've got 3 different simulation areas set up. One of them is just the race car in an empty world, and we can add walls and stuff to it. One of them is a map of the MIT underground tunnels, and this one, yeah, that one's actually more boring than it sounds. I was really impressed by it, but it doesn't have that many ways. And this one is actually a racetrack. This isn't the racetrack we use for the competition, but it is a functioning racetrack. So what the car runs on is a PD controller, and so there are essentially 2 competing parts of it. I'm not going to bore you guys with the full breakdown of the code. Here, I'll put it up while I talk about it, though. This is what makes the car run. Without white space and comments, it's only about 40 lines, which is pretty nice. I think it's pretty slick code. What it's essentially got is it's got a laser scanner on it that looks out in about, depending on whether it's the car or the simulation, in between 240 and 270 degrees, and just gets you the distances that everything is around it. And so what this is doing is it's 2 competing measurements that the car is trying to solve. It's trying to get to a set point where, in this version of the code, it's trying to be in between the 2 walls. It's also trying to minimize the angle that it's at to the 2 walls. So it's trying to stay relatively straight, and it's trying to stay relatively in the center. Ooh, it's getting excited. We have to kind of set how strong the 2 are, so that the car will turn, but it won't slam itself to the side. So it kind of does both. And you can actually see that when the car runs. Oh, that's the terminal, not Gazebo. This is Gazebo. And you can see it's actually set up to test those 2 things. There are a couple pretty tight turns. There's the one right here, and those are to test that your car does turn hard enough. But right here, this junction and this junction is the worst. That's going to test to see if the thing that makes the car not want to be at an angle, that's going to test how well that works. Because if that doesn't work, the car is going to veer right off the race course into this area. So we're going to run it right now. I've already tested it, so I'm pretty sure it still works.
Does it just watch the walls, or does it also watch other cars?
It will pick up the other cars. Right now, it's only looking at the wall. Right now, it's only looking at the walls. On an actual race course, it would look at the other cars. It isn't great with moving objects, but when you get to the actual race, none of them really are. So they test all the cars just for the runtime individually, and then at the end, they do a giant chaos run, which is pretty fun. So it's just a Python file. I'm just gonna.
And as part of this, what they're asked to do, what they're introduced to, is a pretty good mathematical concept where they're designing the control system. They're introduced to the concept of a proportional integral derivative controller, so PID controller to navigate the steering. And this is an example of the code kind of going through that.
Yeah, just to touch on that pretty briefly, it turns out when you're on kind of a smaller thing that isn't running for over very large distances, the I part of that, the integral part, doesn't matter as much. This is just a PD controller. But the 2 parts I mentioned earlier, the proportional controller is what's trying to get it to the center. The derivative controller is what's trying to keep it at not an angle to the wall. There's also some trig involved to get the angle to the wall. So let me just run that controller for you. So you can see the car starts to turn, but it evens itself out pretty quickly. The car starts slightly off-center. This also has a built-in safety, so when it sees a wall in front of it, it's going to kind of try to slow down so it can get a better sense of what it's going to do next. So you will see it turning a bit at corners. That's too far.
And that, the plane of like blue light coming out in front of it, that's the visual representation of the data coming off the LiDAR. That's what it is. It shoots out laser at between 270 and 240 degrees, depending on which way you're running it. And in each one of those, the sensor returns a range value that then is processed and put into the code to generate the error and be put into the BID controller and all that.
And also in the simulation and in practice, the car is actually running a lot faster than it looks. Simulation is only running at like 60% of real time, but it's behaving as though it's going much faster than this.
Does this course exist somewhere in the real world?
I don't know if it still does. It definitely did for an extended period of time.
I think that was the first course. That
They've changed it.
I think this was the 2016 course that they ran. Because if you zoom out a little bit, see those Sam, you see those like pillars? I remember watching the video
pillars.
and the pillars.
They've now taken over on August 4th. They'll take over the entire Johnson Ice Rink and has windmills and bridges and all kinds of obstacles.
So they used to have a finals course that was based on the Grand Prix course from South Boston. Do you guys remember when the Grand Prix was going to be in South Boston? So they modeled a version of it for a race car. Yeah. Had all the street names. A Street.
Yeah, so you can see it's just about completing a lap. There are a couple parts here. Like I said, this part right here was horrible to try to get the car to go through correctly, because that's measuring if it's too sensitive to turning. Right here is kind of the opposite even, because it's like, oh, the car doesn't see anything in a lot of directions. What's it going to do if everything's far away? So the car just made it a full lap. Yay. So that's just essentially how the code works. Car goes all the way around. And it's pretty cool, just based on the data of the walls around it, the car can navigate itself autonomously around. And a lot of real-world things, like Tesla's a little less, but definitely the Google cars use pretty much the same LiDAR that we have, just bigger. So yeah, that's basically how it works.
So, see if we can do a little demo with this one. I think I got some stuff worked out.
Yeah, the car's been acting out a little bit, so we don't have this code on it yet.
Put this thing, can you put it down? Put it down up there. And then you can hold this.
You should aim it at the tripod.
And we'll, so this thing has has wall follower code, so it probably won't run. Wait, there's
Not a lot of room to move around here.
And this thing should.
Nothing's up on the board right now.
So you can
Is this working?
if you can.
Yes, because I'm stopping it right now. But
I'm gonna back it up.
And if you want, I can back it up.
So posts aren't large enough to be detected?
So that's like one of the things
Yeah.
with the LiDAR, it can be a
So
little.
the LiDAR has a 280 degree spin, and it's got 1,081 points per second, so it's going back and forth. So it's picking out a range to pay attention. It's trying to determine a safe distance. So let's see this.
Whoa.
I mean, it's better if there was a wall. It's going to follow the wall. It's probably
And the car's definitely been acting up a little bit, so that's why we did that on
So
gazebos.
this thing
'cause
should probably go across on the wall. See.
The chair's in the way.
Yeah, the car's just been acting up.
Yeah. But the idea is you're getting an error and you're producing a steering angle trying to stay off it, and they're trying to perfect some code. And part of what they're able to do is go back in an engineering fashion, look at some code that's already been written, maybe try to improve it. Some they've authored, some others have authored. And being up here today, they got exposed to about 200 other kids that are doing it, so they're looking at some of that. So.
Thanks.
So next
So
year
can
we'll
you
be
give
doing
a spec
stairs.
on what the car is? I mean, it's got a couple of boards, it looks like.
So right now it has a Jetson T1 supercomputer board.
I think it's a TX2.
And No, it's the TX1, and then we're upgrading to the TX2, right? That's what it is?
I believe so. Yeah,
Yeah.
So the car's got a Z camera on it, and so that just gets like a decent image of what's in front of it. Of course, I already talked about the LiDAR a little bit on it, and the max speed is actually higher than I thought it was going to be. There are some limits on it.
There's a lot of different like speed limits built into the code in various spots because it's an expensive piece of equipment, and there's various points to try to stop you from going as fast as possible every place they can. So, like in the speed controller, there's some stuff that stops you from maxing out speed.
What about the max speed is?
Some people have been like throwing around some like really big numbers.
We've heard a lot of numbers ranging from like 10 to like, we heard someone say 30 once. I don't quite believe that.
Wasn't that if you stripped out most of the pipes?
Yeah, if you stripped out a lot of it, it could go pretty darn fast when it's got,
Because what it is, they took like a top of the end RC car and then gutted it and then put all these all the high end components and sensors and boards and all on it and everything, and that essentially makes it, the components wise, it's almost the same as so it's like the same components and everything as actual autonomous car would be.
just a lot smaller, and a lot less cameras if you want a Tesla.
Yeah, well, considering, I think Elon Musk does not like LiDAR.
Yeah.
LiDAR is good for like a controlled environment like this.
Yeah.
Like if you're like in a hallway or like a maze or something like that. But you need cameras though for a lot more dynamic environments because you can't see the lines on a road with LiDAR.
And another big part of it is like, this is, it's like Ben said, it's simpler. The other thing is, computer vision is really, really hard. And Tesla has put a lot of time and, more importantly, a lot of computational power into getting really good at cameras. But and to get even like, to get decent results with the camera, you have to be able to take a whole bunch of pictures of all around you and then like render the 3D scene in pretty much real time, which means we'd need like 10 more cameras or a really expensive GPU.
And it goes, it ends up going from about like 1,080 points per second to something like 8 billion or whatever.
About 8.5 million points per second when you go to 3 cameras on this car. They have an imitation learning lab they do here in the spring with MIT juniors, and it's when you start trying to do that, even at a small scale, just to understand the machine learning mode that goes into that and how the car is really going to go, that computational expense is one piece, but the complexity of your algorithm to deal with all that pattern matching and to sort out all those different data points is pretty.
It's actually funny that you mentioned that, because just the other day we were during our lunch break, we were like Googling how could we like what would we need to make the car run on just the cameras. And we found a lot. We would need quite a lot to do it. There's this library right now, I think it's called Alice Vision. That's the one I was talking about, that can take a whole bunch of pictures and render them into a 3D scene, but it's like really hard and hard to work with, really expensive. So
computationally expensive also.
And LiDAR is just like, it's very, it's very nice and easy for what we're doing. It allows us a lot more control.
More controlled environment and a lot less random things to deal with.
Yeah.
Like, you saw like even when put in an environment kind of like this, where you have, instead of walls, just like you can really essentially see poles coming up everywhere. Even that throws it off a little bit and confuses it a little bit, just because if it had camera, we'd be able to see all that, but it kind of just sees these dots popping up everywhere.
Yeah, and with robust enough code, it definitely can work with the poles too. Like LiDAR, I know Elon Musk doesn't like it. I personally don't think he's super correct about that. But it's pretty robust. With some decent code, it could probably find its way around this room, no problem. So yeah. Are there any other questions?
Even I've got the AP1, which is the original autopilot, and the new ones that he has out of his heads and tails over. But really, from a driving standpoint, I'm going down a road like Route 30 in Weston. I put autopilot on. It limits me to a maximum of 5 miles an hour faster than the speed limit. If I have cars in front of me, they slow down, it detects that and slows down. And it makes for a much more relaxing drive. But the downside of that is, when you're driving a car, you have to pay attention to what's going on about
to
you.
provide a false sense of security, so you end up thinking you can do more than you can do. If you're thrown into a situation where you have to actually do something, then you're not as aware from the get-go.
And I think a big part of this is that this is kind of a different application than we hear a lot about with self-driving cars, where a lot of self-driving cars are about passenger transport and taking people from place to place, whereas this isn't really about that application. It's more about something roughly this size that they would deploy in an area that they know nothing about. And so real cars can use a lot more GPS knowledge of what's around them. For something like this, who knows, we were actually learning about the potential of using this for some sort of disaster exploration or something, going into an area that we don't think it's safe for humans to go into and getting a nice 3D map of the area. And if it's, if something bad happened, it could be smoky, it could be foggy, camera could be rough, scene could be too complicated. And in something like that, the LiDAR just makes it very clean and efficient. It's a lot better to use a camera when you're, getting people around. For something like this, it's a lot more optimal.
Who created the gazebo software?
We're not actually sure, but the MIT race car team configured it a lot.
So it's kind of mapped to the hardware.
Probably
that's
from
out.
Willow Garage.
Yeah, the ROS
Ross guys did.
The ROS. So that was the other question, which is, so the ROS, the operating system stuff that you're using, is this the ROS stuff from?
Yeah, so we have ROS, and then a lot of it's been optimized for the race car stuff that we're doing.
Yeah.
So there's general ROS, and then this is has a bunch of extra packages and modifications and that sort of thing to make it optimized for.
I don't know how much anyone here has used ROS. It's just a framework for sending messages from one program to another. It also it surpasses languages, so it doesn't matter what they wrote their code in. As long as we use ROS, we can get the laser data in a really nice, convenient way, and we can send the drive message in a really nice, convenient way. It's essentially all ROS really is.
One of the nice things of ROS, Robot Operating System, is it's a distributed piece of framework, and you can run different components of the ROS nodes on different machines as long as they're on the same subnet.
It's very modular, so you can have a node that you don't take it down and replace it with another one, and as long as it's subscribing and publishing to the same things and doing the same sort of thing, it's really, you can do a lot of code based in with it really easy.
I saw a question right there.
Yeah, I just wanted to mention, if you're looking for doing search kind of stuff with it, did you ever hear of Glitch Tech?
I haven't.
Glitch Tech is this hacker maker. He makes a lot of bots. He more focuses on drones than ground vehicles, but that's one of his primary things, because he actually had an uncle that got lost in the desert, and it inspired him to make these small drones that you can launch from a slingshot kind of thing. And but he enters all sorts of competitions and stuff like that. He might be able to give you some inspiration on that kind of stuff.
You'll have to check it out.
GLYTHGCHTEK, I think is his.
Yeah, a lot of the BeaverWorks programs are centered around not necessarily how is this going to work in a commercial aspect, but actually a decent amount of them. I think some of the drone ones too say what if this was deployed in an area where a human couldn't safely go. That's even part of why there's the camera on there, to look for things like that. Yeah, it's a pretty interesting field, because it's a lot of use for autonomy and something that people don't immediately think of, but it's very practical.
Two questions for you. First of all, is the plane of the LiDAR parallel to the ground surface?
Yeah, it is parallel.
As long as the car is parallel to the ground.
Yeah, and the follow-up question I have for that is, in the code that you've written so far, do you compensate for any alteration of that, the angle, to be able to detect, for instance, I was having problems here with the steps, so if you were able to get it at an angle to detect smaller objects than the height of the LiDAR, or I know many years ago, before we made made so much progress with autonomous vehicles. DARPA was doing an annual contest of autonomous vehicles, and one of the challenges that they were experiencing was with LiDAR vehicles, the motion of the vehicle was giving dramatic variations of readings as it bounced up and down and maybe even go infinite as it pointed up. So I'm wondering if you're compensating for any of those variations for a rough course.
So yes and no, because like we definitely designed this code considering that like both the gazebo course and the actual race car course are like mostly flat. However, we did have to take some of that into consideration, partially just to make robust code, and partially because there is actually a section of the final race course. I know in previous years it was a really steep bridge, and not to boast, 2 years ago we were the only team that made it over the bridge on the first try. So yes, we do consider that. Because we don't have to go through tons, we don't have to consider it too much. What you said about the, like, if it sees something too close, like if it's pointing down, we probably still want it to stop anyway, or we want it to act like that's something in front of it, so that doesn't tend to be too much of an issue. And I did actually put a little thing into my code that if the car sees something that's farther away than a certain distance, it will round it down to that certain distance, so the car wouldn't freak out if it saw like an infinite distance or something. So it does compensate for that, but not in a like super efficient, super considerate way, because that's just more like an extra consideration we made rather than something that we like need to do.
It's not like the main focus of it. That's just kind of like a side problem that we really haven't had to address in the problems that we're dealing with.
So you considered it, but you decided that was out of scope.
Yeah. We put in a couple like basic measures just because things do happen, cars bounce, but we were operating under the assumption that we weren't going to be driving over rough gravel or anything. Any other questions from the room?
We can do a little demo maybe afterwards outside in the hall where it has a wall. You can see it. We're not quite sure how it's going to act when it gets to some of the decisions with the code, but it's good to test it in different environments. One of the things we were able to do this school year is to build the first term. We had 13 kids in a 2-term long, so half a year. They were able to get through most of this and really get a wall follower going, and they got some our remote visualization going with it, so they could project it off and they could record some of it, play it back. And then from January to June, we worked with just a small group of two kids actually and designed some machine learning pieces using linear regression as a supervised learning model. But then as you branch into the neural nets that are so popular in the marketing news, you start to get into what are called hyperparameters. And just for this small model on this machine, there were about 200 hyperparameters. So that you can see the complexity just exploded. So they got it working after 2 weeks. The car would just go in a circle, even though it was trained on the same data that with the supervised learning, it would drive perfectly, make all the turns. But then if you had an open door where you didn't have one before, it might turn into the open door.
And not to bounce back a whole bunch of minutes, but that also sort of has to do with why we aren't using cameras, is because like I have done some work with neural networks last summer, and they really are like very complicated, complex things. You need a lot of data, and big companies like Tesla have that. Whenever you do a CAPTCHA for Google, if you label like stop signs on something or crosswalks, you're feeding their machine learning data by labeling their data for them, which is still pretty creepy to me. But so like we don't have access to that massive amount of data. We don't have the power to run those giant neural networks just because we would need more computational power, more time, more data, all that. And like a more powerful car and everything. So that's also why we don't really use cameras, is because neural networks are hard.
And this is really what we found in the last couple of years. This is really the only time that kids encounter Linux in their entire 12 years in school. So.
Except when they're using their phones.
Yeah, right.
Or Chrome encounter
or TVs.
Yeah, there are TVs, yeah. But knowingly, right?
Yeah.
So it's an attempt to demonstrate that, and we find even in the programming courses they're trying to teach, it's just a lot easier to do. Linux is made to do things with. And it actually works a lot smoother. So hopefully we're starting to use this as a proof of concept to try to have an effect on public education too. So that's great. Thanks. All right.
All right, thank you guys.
Very good.
Thank you. Also, if anyone wants access to any of that code, just let me know. I can send it to you.
Yes, please.
So I guess Brian's up next?
I think Brian's up.
You guys okay if I do a quick,
Sure.
if we hit the lights, whatever we do? This was Kurt's great idea at the last minute to, I thought this was a great idea to have this anniversary, get together, right? And so Kurt was like, well, bring along the bag of tricks, sort of.
Yes.
And so, going back to the Solar Wireless Mile stuff, that, I don't know if people remember, what year was that, maybe, that we did the thing out in the parking lot with some...
So I'm thinking,
Oh, yeah.
It's 5 or 6
2011, or was it further back?
So there was a stretch back. I remember my first introduction, I think, which wasn't all that long ago, but it was Sage when he was doing that talk with you on the RoofNet stuff.
Yep.
That came up, and that was one of the early going. So anyways, these are just sort of accumulated bits of hardware from over time. And I think Federico probably could, he's probably got more in his back pocket than I've got in these bins. But actually, and this is a bit of a lost leader so next month, John kindly asked if we could do something on the Raspberry Pi 4, and so we'll do that. We'll do kind of, unboxing and some demo and some talk, and I pitched the idea to a few people who are in the room tonight that the theme of the meeting will be based on, how many people saw the movie Tron back, on,
Yeah.
so a fair number, right?
So saw the reboot.
You saw the what?
The reboot?
What was the legacy? The
Tron
second
Legacy.
part, right? So the idea is to do kind of a Tron Rev 2 update, which of course that was the inside the mainframe and all the kind of cool stuff like that. And so this will be inside the Raspberry Pi 4, and we may even take some inspiration from the cars and stuff like that. So anyway, so we get our Pi 4, but I did, and this is stuff that, and if you have any questions, let me know. And it's intended to be a Linux themed thing, but this is like sort of flashback, and Kurt and probably a few other people can appreciate it. This is like a guessing game. Do people know what this is? So, yeah, the Shiva plug. So this is the Shiva plug. Who makes it? Who made it? Who?
Marvel.
Marvell. Marvell, right? Not
It's a
the
Marvel chip, but the device was made by Global Scale.
By Global
That's
Scale,
right, yep.
was it?
Yep.
So these were the first. This was around the era that we were trying to get something that had reasonable processing power, that we more or less could run off of, like batteries or solar panels or stuff like that. And so I remember that, and these were the guys who were out in the parking lot with us, and the guy came along, and we literally, these were like the first ones that were made, and is
it signed by
it says Global Scale right on it. Sean, man, you're good.
There was somebody else besides Global Scale that made these, right? Weren't there two,
There was one other distributor.
like a Dream plug and a Shiva plug or something?
No, they're all Global Scale, but I think Marvel licensed this design to somebody else.
Oh, right.
Actually, right. And so here's the box, the Shiva Plug development kit box, which was, and I remember when the guy came by, I'm sorry, I would have to dig out his name. He was a very nice.
Rabi Khoury.
You remember him?
Yeah.
You got a good memory.
Well, so he invited us all out to the plug-in in San Jose.
Yeah.
And this was like just Shiva plugs. Nobody else had anything to bring to. No other company was doing this, but they had plugcomputer.org, and you could go and find out about. Something that plugged into an outlet and gave you a Wi-Fi signal. Brilliant, right? Some of them had like 4 Ethernet jacks on it. Come on, that was brilliant.
He was totally super smart, totally nice guy, and they were very good. That company also made the mesh chips that went into the one laptop, the OLPC things.
That's right. Really?
Yeah, they made
Yeah.
they made the mesh wireless networking chips.
And was the processor like a geode or something, or was it some sort of a sock?
Shaka probably knows, but
PC had a Geo.
Okay.
Yeah.
And it was one big sock, or was the Wi-Fi separate and
The
everything?
Wi-Fi was separate.
Okay.
It was not on.
now who made the Geode?
It was AMD.
It was, but at some point in time they had a Marvell chip. I think maybe that was the.
No. So there was I think the networking chip was made by. I think it was like some Broadcom chip and a Marvell chip.
But the processor.
Yeah, okay, yeah.
So this is going way back into
The
the
Geode was a national semiconductor before it emerged, so it goes way back. But a couple of things on the Shiva plug, because it was in the news last week. So this is a 10-year-old design. They announced last week.
To stop it.
This is the last week you can order
Yeah.
Shiva plug from
No.
the original.
Right.
Now it's being replaced by what is called Shiva 64. It's the same thing, but with Wi-Fi and I think on extra Ethernet. And the cool thing is that it's an ARM-V8 chip, so you can actually run software on it.
Is it a Cavium?
It's I don't know. I know it's another
Yeah.
it's
Okay.
a newer model.
It's Marvel's original, not the stuff they got from Cavium.
All right.
So I'm kind of hoping that somewhere in this bin is, I don't know if you saw in the news this week, the guy that got the high quality video tapes of the moon landing, which the NASA inadvertently sold at auction to him for $227.17 a few years ago, and he sold off everything for like nickels, but his dad said you probably should hang on to those. The moon landing, like the highest quality, absolute best, and they're going to an auction Sotheby's for $2 million this week. So maybe there's something in this collection. Anyways, so in the historical context of the anniversary speech, so this is an IBM WorkPad. Remember what this used to be before they, with the, and I actually don't know if, oh yeah, there is a stylus in here. Remember, it's a shame when you get the young folks who are in the room, but once upon a time you couldn't use your finger, you had to use a stylus, right? So, and then remember the Palm Pilot?
Oh, sure.
The original, how many people had a Palm Pilot?
Yeah.
Come on, total geeks. Total geeks. All right, now this actually is this is an MIT connection, and I'm not going to tell you what the name is, but and I'll try and cover it up. But does anybody remember what this is? What this was? What this? Anybody saw this before? So I'll give you a hint. The company was Motorola, and they came and they did a big thing at the what's that big auditorium across the street there? Kresge, right? And it was basically first there were pagers. They'd just go beep beep and give you a phone number and you'd call. This was like the first QWERTY kind of keyboardy thing. So it was two-way messaging. It predated, and it was a Motorola thing, and we had some different discussions on that. And then there were these other things in here. Like, here's one, Dell Axum. Did anybody have a Dell Axum, which was another? There's got to be. This has actually. This I wonder what's on this. That's an interesting. How many? 128 megabytes. Probably cost about $300 when it was purchased. But the leather case is priceless. And now this is another one. To kind of go back and actually there's a story here for those of us who once upon a time I worked at Lotus, and of course it was in the news recently, or somebody sent around a really great historical of Mitch Kapoor. Somebody just sent it out today. And another one that was in the news was the original killer app, which was VisiCalc is what it was kind of. So there's the Kapoor and Bob Frankston and stuff like that, and other people. Anyways, so the story is at Lotus that a guy had, it was a spreadsheet company, and the guy, his name will come to me, he sat at home one weekend and he carved out from balsa wood. He had this idea of, wouldn't it be great if you basically had a hardware brick that you could do a spreadsheet on, right? And all he did is he carved it out from, I don't know, airplane wood or something like that. And in fact, HP went off and they built it, the Palm Top PC. So this was the kind of original mobile handheld from HP. I'm not sure what vintage it is, but somebody could probably look it up. It's an HP, of course, the IBM 360 mainframe. People knew that stuff, right? HP 360 LX. So somebody could check what the date is on that.
Yeah.
But
I had the HP 100 LX. I'm wondering which came first.
oh boy, this is trivia. I'm not sure. Maybe we could. I wonder if I've got a stylus. If you've got a charging cable, we could. I don't know if this has any kind of. Do you have any recollection of what? I mean, it must have had memory of some sort, or I don't know how would you. It's got something here that you'd. I don't think it's big enough for a floppy disk, but what would you do with it? Do you remember? What did you do with it?
So it had a modem port, and I used it for mobile. You could actually have 9600 baud modem, and I had look it up, and I actually sent my daughter's birth announcement from the hospital
Wow.
using that, SSHing into a machine. And,
Wow.
and sending me an email from the hospital in '96.
That's total geek, because what I did more or less the same thing with the cell phone, and then around that time, and then we submitted it to, I forget who the cell phone carrier was at that point in time,
all over the table.
and they gave us like $100 gift card for the what a dumb thing for you to have done. Why don't you pay attention to the kid?
Yeah, I remember my first year in college, my first computer was the Radio Shack Model 100 laptop. You wouldn't have to have one of those,
1997 for that. So you've got something 95, and the thing I referred to was 93 with the phone. Anyways, there's a bunch of other stuff in here. ED Max, remember the ED Max, the radios and stuff?
Yeah.
Actually, remember there were a bundle that you had.
That's right. Yeah.
Right? You were doing some wireless testing
Yeah.
in somewhere, which you can choose to talk about or not, Kurt, if you wish. But the ED Max folks, I don't know if they're still around, but they were big, you know.
They make Wi-Fi dongles.
Wi-Fi dongles. They were, and so what we were trying to do is we were trying to get a little device that that could be run off of batteries and have wireless. And so we were piecing all this junk together. And so at some point went to the bigger form factor, right? So and actually Shankar was one of the best pieces of advice I ever got. So I built a bunch of these things, just motherboards and cases and some kind of a drive and. The Atom-powered boards, and so they're really good because you can use Linux, reliably without a whole lot of everything just installed beautifully. They weren't real expensive, so you could throw memory in. I built a bunch of these with my kids actually, and but the best advice was from Shankar, which is, well, try it with an SSD drive on it, and it was like, I spent hundreds of dollars to get faster processors and stuff like that through the SSD drive, and it was like my wife has continued to use that machine for like the past 5-6 years as though it's it's the best machine in the world. And so Kurt will remember this. So at some point, our goal was to put one of these systems that we into a NEMA 4 waterproof box kind of thing and hang it off the bridge, and which we did more or less come close to doing. And we had set up these big antennas on the MIT bridge, right?
Yep.
And we had a signal that actually at least got
Got over to the solar concentrator on that drive.
the solar concentrator, right? Is that still there?
The frame of it is. It's pretty much.
The glass.
All the glass is gone.
The glass is gone. So this is fast forward right through a bunch of it. Now everybody's got laptops. I don't know if they're running Linux on. You guys running Linux on those up there?
It's a VM for some of us. So 50% native Windows, 50% native Ubuntu. We've all got a VM with it.
So then we all went through the iterations of. So who started with just shoot out what your first distribution was that you used, Debian?
Slackware.
Ubuntu. Slack. So a bunch. So
The first one I tried to install was SLS, and then when I couldn't get it working, I got some advice from someone who, as soon as he heard that, he said, "That doesn't work anymore. Use Slackware."
Interesting. So at first, they weren't laptops that we presumably installed on. They were desktop computers, right? Which you wiped out your Windows stuff, and it was really hard getting cards that worked, whether it was wireless cards in the early days, certainly of Linux.
Sound cards took forever to work.
Which sound cards?
Yeah.
Right. You didn't need sound, and so you didn't use Yeah, that's good. What else didn't work? Video? Video was always kind of.
So we had a guy.
Cards were, to get X working was like, you had to set all the mode lines for your stupid monitor. It took forever to get it working reliably, so that you rebooted it, it would come back, and X would be actually working.
Right.
We had a guy speak here
95,
once.
96.
We had a guy speak here once that we found a distro watch. Remember distro watch?
Yeah.
So we were looking through distro watch, and there were like 1,000 distros back then. Again, hey, this guy's in Massachusetts. Let's get him to speak. And he had this distro called Dead Man Linux. Well, that should have been our first clue, not to have this guy speaking. Do you remember that joke? The guy was a complete nut job. Showed up, he had like black paint under his eyes and stuff. I think he was a goth before that was cool, I guess.
Yeah, I've totally blanked out that.
that sounds like it's probably a good one to blank out. He may have been blanked out as well. But somewhere along the way there was a meeting. Remember when Google came in with Chrome OS? And so I don't know if you remember that, but there was a meeting where folks from Google came. I don't know what year it was, but it was Chrome OS. I remember compiling it, sitting up on that row up there. It was source you could download. Like 3 years before the first Chromebook came out. They came, they talked about it, and it was just a variation of Linux that they had customized, as I recall.
It must have been more than 10 years ago.
You think it was more than 10 years ago?
Mm-hmm.
It was a while ago. It certainly predated, I think, Android and stuff like that. And anyways, you could compile it on your own machine while you were there, which we did. And then fast forward, actually, you get beyond, of course, the big clunky desktops where you didn't have audio sound, you didn't have video that really worked quite right, and networking was wireless and stuff like that didn't work. But and eventually now it's just everybody's got it easy. Just like you get a DVD or go online and just install the stuff. And so more recently, this is probably 2, 3, maybe 4 years ago. So these Acer things came along. I don't know if people remember the Acers, but these were the first of the really kind of...
Those are 10 years old, too.
Are these 10 years old?
I still have mine.
You still have yours, yeah. I have one in black, and then I have one in vanilla, and they were like about $350 or something like that, right?
$99.
Now they're $99, but unfortunately...
10 years ago, they were $99. That's why I bought one.
The current Acer one is like 130, 140. It's a little bit wider. It's still unusable.
Yeah.
I bought them like four of them back in 2008, and they were $99 when I bought them.
Yeah. Mine, unfortunately, when I first bought them, were closer to $299. So I was a little bit, you got the remainders, I think, which was a smart move by you.
Brand new.
But what are they? How many gigabytes? It's RAM, right? So it's no hard disk, no hard drive. It's longer battery life was kind of what the appeal was. And so this one, I haven't probably turned on in probably 8 years. And of course the battery was dead, and I plugged it in. But as soon as I plug it in, it comes up. It's like, oh, Linux Mint. I had no recollection as to what was installed on it. And of course it works, and I updated it fine. That's pretty. Could you imagine doing that with another platform and actually have the installation work? Probably not.
Windows XP.
For instance, pick any, I wasn't going to go there because the video recorder is going, but no, nothing. It wouldn't work. Not, what you would do is with a machine like this is you would, you'd wipe out, you'd put Linux on it because it would work. And so, so this to me, when I bought it, it was closer to $300, and then later on came these. These are HP. I don't know if people have ever seen these. They stream. What's the brand? Yeah. Streams. HP Streams. Yeah. Mm-hmm. Really, some of the again, they're all RAM. No hard drives and stuff like that. Low cost, versatile. It's got basically everything you need for a couple of $100. I don't know what they are.
What was this one called?
This is an HP Stream. HP Stream. Stream.
That was supposed to be the competition to Windows, right?
Yeah.
Windows had some ultra light, whatever Windows version that was supposed to be optimized for.
So you can get these. You can get these at Walmart for I don't know,
$100 or something.
Something like that, and you can get them in blue and purple, and they're really durable, and they come with Windows on it, and it was effortless to install Ubuntu on it as well. So they're really rugged and durable and disposable. And then so fast forward again, and then this would be the kind of the closure on it. Of course, was the Raspberry Pi. So those of us who were around when the first again it was, isn't this wonderful? Smaller, cheaper, more energy efficient. And when they first came out and years ago, and they said, man, we're going to make one of these computers on a chip, on a board kind of thing, an SoC, whatever, for $15. That was their original, I think. They were academics, and you figured for sure it would, if this ever happened, it would be marvelous, but it never will. But anyways, and it was the same guys. And Kurt, you've been in touch with them recently, haven't you, after the release of the Raspberry Pi stuff?
Yeah.
So
they came, so Evan Upton was at MIT. I think he was coming through here to talk to John Masters, for instance. So those guys knew each other from the old world, and so he was in Cambridge, Massachusetts, and I said, "Could you talk about Raspberry Pi at MIT?" And he had like serial number 1 with him, and it broke when he was flying over.
Right, the SD card slot broke. I remember that. Yeah, yeah.
And so we were like, well, if it was going to break anywhere, this is probably the place to break it. Because I know there's a couple guys at BLU that have their own ovens. Maybe we can float.
Right. So the beauty of it, and then they came out with these with the little ones, right? With
The zeros.
the RPi Zero, you know, and then if that wasn't enough, then they threw wireless on it, and you know, and it runs full blown Linux, which is pretty amazing. The new Raspberry Pi 4 they've sort of spun a new distribution to work with it. But yeah, observations. Anybody worked with the Raspberry Pi 4? Yep. Yeah.
No, I worked with a Zero for a school project where I had to put a Python script on it, and I had a motion detection script on it. So every time you would pull a tissue from a tissue box, it would play music. And I was using the Pi Zero, and yeah.
I mean, for $5, you know, it's pretty amazing, isn't it?
Yeah, it is.
$5. So I picked these up at over at Micro Center, the place that shall be, you know, not named or something like that, right? But I mean, $5 you can get it. So if you can't have fun with that, in terms of all the stuff you can do, whether it's, you know, it's pretty amazing, right? In between the things that we in the past, the Beagle boards, of course, from TI, certainly worthy of note. Any others that, in terms of boards that can run Linux, that we should be mentioning in the evolution?
Panda boards.
Yeah, Panda board. Well, this is really too noisy to do while the camera's running, but we'll also do a Panda board thing at the install festival. Yeah.
So great history. Anyways, that's all. Any other questions or thoughts, or anybody else have things from?
Remember those Genesi netbooks or whatever?
Yeah. That's a really good one. So Bill Buck and company, they had, this was a company, and I think they actually had, the design was done out of Germany or someplace like that, and it was, you know, kind of similar form factor, and they were sort of boxes, and you know, very clever. And I'm trying to think what changed after. I mean, there was an inflection point where, you know, people were trying to come up with these kinds of different things. And I think that probably was around the time that Raspberry Pi came out and just totally changed the economics and the technology curve. You know, the other interesting thing about Raspberry Pi stuff is that, I mean, it isn't a complete system. You know, even to this day, you got to buy a separate power, you know, adapter, and you got to have your own keyboard, and and I guess the whole maker revolution kind of came along. And then of course what are those other little chips out of China that have the wireless stuff on board, and they're $15 and
ESP826.
the ESPs,
Yeah.
right?
The ESP32s.
And now they're 32-bit, and before you know it, maybe they'll be 64-bit. Who knows? But yeah.
You know, Arduino originates from Linux.
Great question. So that was another sort of, you know, side detour for some of us, the Arduino stuff. And, you know, Sage was really a master of that stuff, right? And so I think the short of it is no, that and I don't think there's any real, because it's basically operating system free in some sense. But so that was the whole side track of controllers, right? The idea of, and Sage, I think, was the connection. So Sage was doing the Arduino stuff for the solar powered car, right, for MIT.
Yeah.
And I don't, have you got like Arduinos on the car here?
There's a NVIDIA Jetson TX1 on the original. There's the TX2 underneath it, just upgraded today from the newer image. So they moved to the TX2 to support the computer vision better.
So, Kurt, maybe you could just give a brief on the solar-powered car competition, because although it's, you know, it's tangential to it, but that thing was loaded with these Arduino chips as controllers for both, you know, making the energy consumption more efficient. And Sage, I mean, he was actually working on that project, right?
Yeah, and I think if they were to do it that way now, they'd go to the ESP route. So Arduino, as you know, has kind of a storied past. The two founders had a falling out, and one of them moved to Providence, Rhode Island, and started a bunch of Arduino companies. And then they have since come back together and revisited their original open source intent. So now Arduino, the general trademark is now the dominant trademark. They had two different competing companies for a while there. But yeah, all of your, for the solar side of the solar-powered supercomputer and the solar-powered car and everything like that, you have to have a lot of microcontrollers on there. You got to have maximum power point trackers, and so that was where Sage really excelled. And so I'll probably at the August presentation, I have discovered a bunch of photos from the early days of, we found out that if you pull a partial vacuum underneath something rubber, it gives you the bottom of a parabola. So we set up a solar-powered concentrator with this thing that all we had to do was just basically put a little metallized mylar in there and make sure that the tripod was a sufficient, whatever you call the distance between the bottom of the parabola and the focal point. Is it called the focus, maybe? No. So I've got a bunch of pictures of that, and we really screwed over the Harvard Regatta one year because on the water side of MEMDrive you had to pay $500 for a spot. But we found a place that the city of Cambridge gave us for $25.
Colonel Burns Park, but with basketball courts and tennis courts. Yeah, they gave it to us for free, basically.
Yeah.
And we launched an air balloon with wireless.
A weather balloon with our SSID on it, so that everyone on the Charles River could see our free SSID. And Sprint was renting dongles at about $100 a day. So Cambridge Public Internet was free for everybody that had it.
So in August, what we'll do is we'll work the Arduino, and the whole operating system story into the Tron 2 themed. And everybody has a character in mind that they would like to be in this script. Please let us know, and we're going to work it in one way or another from the BLU history. Yeah.
Yeah. So I actually teach several different Arduino classes at Watertown Makerspace, and that's kind of the number one question I get asked is, Arduino versus Raspberry Pi. Before we give it to what do we do? What's the big difference between them? There are some pretty huge differences, and all my courses have multiple slides on them because it's an important distinction from what I just did.
Yeah. I mean, we're all spoiled by the choices that you have, So you can get a bucket of Arduinos for a few bucks, and if you've got the skills, you acquire the skills, you can really do amazing things with it, whether it's holiday lights or or whatever. But and likewise, you can just go down the store and pick up a $5 thing that runs Linux and just have at it. So.
And the fact that the Pi W is cheaper than an Arduino is.
Yeah. No, it's it's just incredible. So yeah.
I just wanted to throw out there when we're talking about Arduinos and Raspberry Pis that there's a new kid on the block, relatively speaking, with MicroPython and CircuitPython, in large part promoted by Adafruit. And I think it gives a nice sweet spot between being able to program in Python, a quick-to-learn language, that normally you need something as powerful as a Raspberry Pi, but it has the power consumption and form factor of something like a small Arduino, or even smaller.
And that's a great shout out to, Adafruit and what they're doing. It's just unbelievable in terms of bow down and Kurt knows, from Lady Ada from her days at MIT here. But it really is amazing how much they've contributed, it seems, to the whole community in terms of really hard to do software and packaging and hardware, and they've got a business that they've made out of it. More power to them.
I think the interesting distinction, the key distinction between Arduino, ESP32, and CircuitPython on one side, Raspberry Pi, BeagleBone on the other, full systems on the other, is that on one side you're on bare metal, but you do have a real-time system if you want it to be real-time. So networking is going to be a nightmare, but as long as you don't have to deal with networking, the rest is reasonable for real-time control. While on the other side, you have the full Linux stack, so you have as much software as you can possibly want. But then real-time control becomes a little bit harder. Networking is trivial at that point. You just have the CPU right there.
with the circuit pipeline, Influke makes Wi-Fi boards for their Feather form factor and the other stuff, and provides the library, so even TLS is trivial on that side.
So that's their like
Yeah, they're basically putting an ESP32 just for the networking and attaching it to a regular Arduino.
Right, I've seen that. And there are some older Arduinos like what's the word for it? The Moon that has basically a Docker board running with Linux on it for networking.
So that'll be it for me. Thank you very much,
Thank
Jerry
you,
and John.
Brian.
Appreciate it.
One of the things that's sort of been lost in history is on some of these devices has been the infrared, the IRDA, which used to be a popular way that you could actually send small files. Except nowadays, the only time you see infrared on a cell phone is these ones that are in there with remote controls.
Nice recall or continue.
Yeah, those Palm Pilots have IRDAs. Those transmit your contact information to everybody else. They have IR. Yeah.
And the cell phone I've got, it actually has the sensor port in the infrared. And unfortunately, the default OS doesn't allow you to do very much with it. It's basically, it allows you to, in theory, receive, emulate remote controls and nothing else. But the thing I've been wanting is I found out that apparently the hardware it's apparently hooked up to one of the chip's internal serial port, and I'm wondering whether some certain modern cell phones actually could do IRDA.
Almost all Apple laptops between 2002 and